So, hello and welcome to a rather weird start to this video. Today we have the second part of the B450 board that we tried to fix in the last one, where we had on 5 USB the shorted USB-C controller, and then on the 12 volt side we had a shorted MOSFET. And today I went ahead and looked at the SIO, because the SIOs are mostly responsible for holding reset and for looking at the incoming voltages from all over the board, all of the power good signals. And what I was doing, because I had really no point of where I could really look at something where I was suspecting a problem, I went around the SIO on every single pin and tried to figure out, okay, which of these are necessary for us, which of these might be important and which are not. But I forgot to record my microphone. So I have over an hour of footage that you can see running in the background, where I was commentating into the nothingness and was checking around the SIO, because we still had PCI reset stuck and the board not moving, having a CPU LED. And yeah, I spent over an hour. I think the raw footage is like somewhere around 90 minutes going over all of the SIO, every single pin, trying to figure out, okay, what this pin is responsible for. Is it high or is it low? Is it necessary for us? But I sadly wasn't able to find anything that was suspicious or not. What I can tell you though is I thought it was pretty interesting to get to know every single pin and try to figure out, okay, is this necessary for our boot up or is it not? I learned quite some things on the way, but sadly there's nothing left of that. So in the background you can see a speed up version of that, but that's all I can give you, sadly, because yeah, there's no audio to it and I can't really talk over that again, because it's just 90 minutes of live commentary that is missing now. But I want to get you back up to speed what I've done so far on this mainboard and at what state we are. So, to get you back up to speed, I spent a long time, as I said before, doing all the stuff around the SIO, where I have lost a lot of footage, sadly, that I can't really show you. Only that what I was able to show you in the background. And I was able to get a friend of mine who also does a lot of fixing into here, and we sat together, one looking at the schematic, the other one looking at the board view and doing measurements. So, after spending a lot of time with my friend looking over this and checking some voltages, we still couldn't find anything except a single thing. And that is, there is a missing signal coming from the CPU, a power good signal. I want to show you that on the board view. On this pin, on this resistor right here, this 300 ohm resistor, it is an outcoming signal from the APU, or the CPU in this case, going into this resistor, and it should have like 1.8 volts or something like that on this side, or on that upper side. And let's check that. The board is now turned on, and if we now go on to this resistor that had a lot of probing already, we see 0.24 volts. So this seems very wrong. This is the 1.8 volt side. This is present, but something on this side isn't quite right. And let's see for the resistance on that side, which is still rather high resistance with 1.3 kilo ohms. But there's a very interesting thing that happens if you try to pull this line up by yourself. So let's go into the overview again. I right now have 1.8 volts attached to my tweezers, and if we now turn this board on, we need to pay close attention to the bottom right. So we turn it on, we have our normal power consumption, and if I now supply 1.8 volts to that power good signal, I have 30 milliamps, and our CPU LED changes to DRAM LED. That was probably hard to see, but we do have change, but there's nothing happening because PCIe reset is still stuck. So we can't got any further than that, sadly. And another thing that we were able to establish is, even if you try to take reset off yourself, as you can see, the red LED right here, and if we supply voltage to PCIe reset, the board takes reset off, but it doesn't go into a actual starting. So what I think happens here is that we manually skip this manually skip this stage of the APU power good, and then it continues, but it never goes into this automatic self-checking function that goes with the BIOS. Just like when we hit PCIe reset and we get it to take reset off, there's probably multiple different things that should be taken off or should be done, and one of those is reset, but all of the other things are still missing for this board to turn on. So I'm at a loss, really. One more thing that I have noticed is that the USB-C controller actually connects directly to the PCH here, and I want to show you that on the board view. So we have this pin on the PCH, which is in the top left, which directly connects to this shorted controller. So if this controller got a gross over voltage, it might have been possible that this also killed the PCH, because these are directly connected. And that's sadly about all I have for this board. I spent probably like 3-4 additional hours on this, trying to figure something out, checking voltages, checking power good signals, going over different kinds of things, and I just wasn't able to find anything. My suspicion is that our chipset is dead. I think that this thing is holding our board in a reset state where it can't move on. I was told by many other people that most of the time if reset is stuck like that, there's probably knocked off components somewhere. But I've been going up and down this board so many times trying to see if anything is knocked down or knocked off or anything, but it just wasn't able to determine anything. And spending all of the time going around the SIO, checking all of the pins, checking all of the connections, I also wasn't able to find anything special. Like, the biggest thing, the most interesting was on the right side of the SIO, there's a lot of V-in signals. Let me show you that on the board view. On the SIO, there's like V-in 0 to V-in 6. And these are just voltages that it monitors, like VDDQ SIO that it monitors. Then on this side, VDDP it monitors. Then SOC SIO. And on this side, it was VCC SIO. Here we had 12 volts that was monitored. Here we had VCC3, so 3 volts that are being monitored. Here VCore that was coming in. And this was also ITAVCC. So just more voltages that being looked at by the SIO, and I don't think that the SIO is a problem. I really didn't see anything that was a problem. And the other thing also is that our board reacts to being turned on by the power button, and this is one of the main things that the SIO is responsible for. I think it is something related to the connection between the SIO and being connected to the PCH and them working together, and maybe even one of these two sub SIOs but I just can't determine it. If I would be able to change out this chipset, I could at least rule the chipset out, but sadly I cannot with the equipment that I have. I cannot change this chipset out. So what is going to be the future of this board? I don't really know, to be honest. Maybe it's going to be for spare parts. Maybe I'm going to be spending some time at a later date on this. But currently, to be honest, I'm just burned out. Like last Saturday when the video came out, I was really determined to fix this board because a lot of people wanted to see this board being fixed. But I've spent so much time and I'm just getting nowhere fixing this board, sadly. And yeah, it devastates me, to be honest. But my suspicion is that the PCH is dead. But my biggest problem with that is that it is a speculation. I don't have like a single signal where I can say, okay, this signal is missing. The SIO should be providing this signal for our board to continue to start up. But I never found that. So I cannot say for certain that it's the PCH. Trust me, I've spent hours also on the schematic or a very similar schematic to this board, trying to find out what the PCH is also responsible for, where I could find anything for the PCH that I could probe, maybe pull up high by myself with the power supply, but I just wasn't able to find what is actually wrong with this board. So for now, we're going to get this board out of the way. Going to be taking everything off, putting it to the side, and maybe someday, maybe revisiting this board. But what we want to do now is actually that this video series should be a video series about two main boards. So this is the one that we've worked on before, and this is the one that we have seen before. That was at the beginning where I said we're first going to be going around the other board. So this time, instead of an Aorus Pro, we have an Aorus Elite. So a slightly different board. Interestingly enough, this one doesn't come with an USB-C like the other board that we have. And we want to figure out what is wrong with this one and hopefully at least get this one working. So let's check the obvious things first that we had similar before. Let's check 5 VSB for a short circuit and the other ones. So this is 5 VSB. This looks good. This is 12 volts. This is 5 volts. And this is 3.3 volts. And 3.3 is a little bit low with less than a kilo ohms. Interesting. Let's check around the SIO. This is down here. Let's just check a random capacitor close to it, and we have a kilo ohm. And I might be able, yeah, this is the 3.3 volt for the SIO. There's a 5-pin regulator always, or at least on these Gigabyte boards, and this also looks very fine. Let's check the voltage of the battery, which is 3 volts. This is very nice. So we don't have any. Oh, one more thing that we need to check for an obvious short is the 12 volts for the CPU. And we have kilo ohms and rising. And yeah, there's a lot of sub voltages that we could check, like VDDP and VPPM or VDDQ for DDR voltage. But I think we're going to be looking at the standby voltage first now of this board, and we're going to see how this board reacts. So let me get it built up and then see. So the board is built up now, and this time we have post LEDs on the bottom right here, and we have CPU, DRAM, so top left CPU, top right DRAM, bottom left VGA, bottom right boot. So, and we're going to have the passive power consumption. Let's see. We have around 200 milliamps, so very similar to the other board that we have. And also the LEDs not lighting up. We have 3 VSB present, which is shown by our PCI tester. As you can see, the green LED on it. So now let's see. Let's turn this on. This takes 1 amp, 2.5 amps, DRAM LED, and LEDs turning up, and VGA, and booting again. VGA right now going on CPU, going on DRAM, going on boot, and we actually got boot. You cannot be serious. Let me quickly attach this to here and get our post screen onto here. I think this board is actually turned on. Let me get a keyboard onto here as well. And we do have caps lock. I cannot believe this. Let's reset this board. Let's see if we can get the post screen on here for you. And there it is. I cannot believe this. Seriously? Oh. Cannot believe it. The other board was not working at all. Had so many faults, so many problems. And this one just boots up? You serious? Okay, I cannot believe that everything is right with this board. Let me get all of the RAM into here. Let's check PCIe devices and let's check M.2 if these work or not. Because I cannot believe that this board just turned on without doing anything, while the other board robbed me of hours and hours of trying to fix a problem that I couldn't find. Let's see. I'm going to turn this off and I'm going to be populating a lot on this board, and then if I find something, I will see you again then. So, the board now is also starting up with 4 sticks of RAM. As you can see, we have boot LED and we have a boot screen, and all 4 DIMMs are recognized. So I'm going to continue with M.2 and continuing with getting a PCIe device onto here and see. And now we currently have an NVMe SSD plugged into there. We have a GPU on here and we have a signal, as you can see right there. And we have a lot of amps, like almost 5 amps of current draw we just had. And it seems to be just working. As you can see, there's the Windows screen or the Windows boot up sequence with the dots happening in the top right. And this board just works. I cannot believe that the second one I got, if I didn't say this correctly, but I got both of these boards off of the same seller for the same price, and they were a bundle deal, and out of luck I happened to grab the one first to work on, which is horrendously broken, which had so many problems, and I still couldn't get to fix. And this one just laying around there is just fine. It just, everything works. Like, I will check the Ethernet and the USB ports of this also, but I've basically checked most of the things right now already. I've checked that the PCIe is working, that the NVMe is working, that the CPU is recognized, that all of the RAM is recognized. And yeah, I don't really know where to go further with this board. I will do some stress tests here with the board, and I will see if I have crashes or anything similar, or if this is just going to work, and then I will get you back up to speed of where I've left off. And as you can see now, we have LinPack passed. I'm going to be running a 3D stress test now for the GPU, but I doubt that there's going to be any problem. And now also our Heavens benchmark has passed. So, we've come to the point where our journey sadly ends for these 2 mainboards. One being fixed, this one fixed. I didn't really do anything, it was working from the beginning on. And this sad specimen that we had, where we tried really a lot to do for this board, but we sadly just couldn't. That's the sad reality for fixing mainboard something, or fixing something in general. You will never be able to fix everything. There's sometimes just problems that are over your head. And I'm pretty sure if I had a better expertise at fixing mainboards, understanding the circuits of the PCH and the SIO, that I would be able to maybe fix this or pinpoint the problem of this board. But sadly, I'm not at that point yet. I can tell you there are like 6 or 7 mainboards to the left of me that been laying in my stash for a very long time where I just can't figure out what is wrong with them. But you need to still try. Like if you're trying to get into the trade of fixing electronics or like fixing mainboards in this case, like I have learned a lot trying to fix this board. Going over this all over the board from top to bottom, going onto the SIO, checking power good signals. There's a lot of stuff I've learned trying to fix this mainboard. But it's still devastating that I couldn't get it fixed at the end. Even though I was able to find multiple faults with it. Yeah, who knows? Maybe in the future I will be able to fix this, or maybe it will be ending up as a donor board. But I want to tell you that even if you can't fix everything, you even trying is very good, because trying, you will acquire new skills, you will acquire new knowledge, and you have to just sink a lot of hours into this hobby if you really want to get good at it. And I'm still learning. There's a lot I don't know about fixing mainboards and the specifics of it. There's a lot I need to learn still, but I still have fun doing it, and should have fun doing it, because you if you get into like a board like this where you just can't figure out the problem, working into that can be really rewarding with either fixing it or learning new stuff, but it also can be very frustrating and burning you out. So even if you cannot fix this board right away, step away, try to fix another board. Will always be problems that you can't solve. And that's how I've been continuing to learn for my repairs. Just if you can't get this board working like I'm on this one, maybe later you can, and try to move on. Surely don't just give up the instant you can't find the problem instantly, but keep at it and keep trying, and maybe move on to another board for some time. But I'm very happy for this video series. It was very interesting for me, like getting into this board. And I hope you enjoyed it. I hope you could learn something, even with me failing to get a proper the proper video of where I checked the SIO with all of the signals around it. And hopefully you learned something already from having where we had the short circuits and some things that you can maybe look into for fixing mainboards. But thank you very much for watching. Who knows, maybe there will at some point be a part 3 to this video where I will be fixing this board. For now, it's going to go in my stash and going to be laying there. Thank you very much for watching. I really appreciate it. And this was Mainboard Medic. Thank you very much and goodbye.